So good morning. So the last two classes I've left some topics, so I've decided to finish them off in this one session. So please give me a minute. Please confirm, is the screen visible?
Not yet.
Yeah, same.
No.
Yeah, now it's yeah.
Is it visible? Hello?
It's visible now.
Yes, it is visible.
So one method which is there in the last of the sheet, like I didn't notice it after my there's actually I had not noticed it, that's why I missed it. Sorry. So this is Lagrange's of multiplier method. Please write the proper heading. Lagrange's multiplier method. Lagrange's multiplier method. So we will see what is this method and why the use. We have to see this. Listen carefully. What we are doing is they are giving you one function. They are giving you f of x comma y comma z or anything, can be any number of variables. Any number of variables, and it's a function. It's a function. Okay. And they're also giving you a condition G which connects all the three, which connects all variables. Some condition they're giving. So now what your task is, you need to find a relation. Your relation is you need to find the stationary points of this. Your task is find stationary points of f which satisfy G. Understand? The method which we learned, like we wrote P, Q, R, S, T, that there is no condition between the variables, just some x, some y. But here what I'm doing, I'm imposing some special condition on the variables. So I need to find stationary points which satisfy this condition. Okay. So how to do that? Listen carefully. Define expression L equal to f plus lambda g. Okay. Define an expression f plus lambda g. Now solve dou f dou L x equal to 0, dou L by dou y equal to 0, dou L by dou z equal to 0, and dou L by dou lambda equal to 0 to get stationary points. Definitely you want a 100% clarity. Is it clear? What 50% is clear. When you do the question, it will become 100% clear. 50% clarity is there. Yeah, hello.
I have a doubt. Yeah, I have a doubt. In that method we saw earlier, right? Finding stationary points, that was only for two variables, and this is for any number of variables.
Any number of variables. Yes, any number
but
of variables.
That
what
was
here
for two variables, right? That the first one.
For two variables. Yeah, because we are defining only dou squared, by dou x squared, then dou squared by dou y squared. We'll have to define z also. We have to take many other combinations. We took only two combination. In 12th level, we learned only for one combination. Remember, f dash, f double dash. So like that. But this is a general method which will work for any number of variables. Okay. So I just look at one question. I'll do one simple question first. Like ma'am's questions are still high level in the beginning itself. I'm just taking one simple question to do it. Give me a minute. Where is it? 1 minute. Okay. So I'm giving you, consider function as x, y, z such that x plus y plus z equal to a. Maximize or minimize the function. Listen carefully. With this theorem, in our syllabus, we can only find stationary points. Like you cannot differentiate between these two. In syllabus, these are not to be separated. Meaning, they will given the question: find maximum, find minimum. Okay. You cannot tell whether it's maximum. You can only say it's a stationary point. Okay. So don't worry about to use a stationary point, but is it maximum, minimum, saddle? That's not going to be asked. Only they'll just say find stationary points. If they say maximum also, you just do the same thing. They say minimum, do the same thing. Okay. Now what I'll do is f will be x, y, z. Right? And what is g? G I'll write as x plus y plus z minus l. Right, like this. You write the condition like this. Okay, clear? Now what to do? Let L be x, y, z plus lambda into x plus y plus z minus a. Okay, correct? So now, what I'm doing? First I'm doing dou L by dou x equal to 0. Do it. What you will get? You will get yz plus lambda equal to 0, correct? Check. I think I'm correct only. Then I'll get dou L by dou y equal to 0. This will give me xz plus lambda equal to 0. Then I'll do dou L by dou z is 0. This will give xy plus lambda equal to 0, correct? What I'll do, I'll multiply this equation by x. So I'll get what? I'll get xyz plus lambda x equal to 0. This equation I'll multiply by y. I'll get xyz plus lambda y equal to 0. And this equation I'll multiply by z. So I'll get xyz plus lambda z equal to 0. What I'm doing, I'm comparing the three equations. Comparing, what you will get? You will get x equal to y equal to z. Am I right? Tell me. So x equal to y equal to z. Let it be equal to k. Okay. I'm telling x comma y comma z is now given by k comma k comma k. Now fourth condition is what? Dou L by dou lambda equal to 0. Meaning you will get, to differentiate with respect to lambda, this will become full constant. This full part will come, correct? X plus y plus z minus a equal to z. Meaning the same condition will come back. You will get back conditions. You can directly substitute conditions. This is the you will get the condition. Okay. Condition given. So now substitute the condition. What you will get? Substitute the condition. What you will get? You will get 3k minus a equal to 0. You will get k as k by 3. So what I can say now? X comma y comma z will be a by 3 comma a by 3 comma a by 3. That's it. This is the stationary point. It may be minima, so we don't know. Maybe minima or maximum. Actually, there's some other method which I saw on YouTube video I saw, but it's not there. Ma'am is not given on it. So it may be maximum, minimum. We don't know. We don't need to worry about that. Please tell me any conceptual clarity, any doubt on this? Tell me. Simple, no? Yeah, tell me. It's simple or not?
Yes.
Reaction class. Understandable.
Yes, understood.
Yes, that's sorry. That's it. Now we will do one more question. I'll do one question from ma'am sheet. It's a little, we'll try, you try this question. Okay. Find the maximum value x power m. This is in ma'am sheet. Same model. X power m, y power n, z power p for x plus y plus z equal to a. Do this. And see, they've given maximum value, meaning they're saying it's maximum. You don't have to worry. You don't have to think how ma'am said it. How ma'am knows it's maximum. Might be minimum also. Ma'am knows it's maximum. That's it. Don't argue. Okay. So what you will do? F is equal to x power m, y power n, z power p, and g will be x plus y plus z minus a. So I'm writing L will be x power m, y power n, z power p plus lambda times x plus y plus z minus a. What you're doing? Dou L by dou x equal to 0. What you will get? You will get m into x power m minus 1, y power n, z power p plus lambda equal to 0. Beta. What do you do? What I'll do is I'll multiply this equation by x by m. You see why I'm doing this? I'll again get back x. I'll get x per m, y per n, z per p plus lambda x by m equal to 0. Correct? Why means I want to keep this. I want to maintain this so that I can compare the equation at the last. You see what will happen. So I'm writing dou L by dou y is 0. What I'll get? I'll get n into x per m, y per n minus 1, z per p plus lambda equal to 0. Know what I'm doing? All this all is just manipulation. Okay, you need to just be smart and manipulate. I'll multiply by y by n. So again get x per m, y per n, z per p, lambda y by n equal to 0. Then what I'll get? Dou L by dou z equal to 0. What I'll get? P into x per m, y per n, z per p minus 1 plus lambda equal to 0. What do I multiply it with? Multiply it with z by p. So you will get x per m, y per n, z per p plus lambda into z by p equal to 0. On comparison, what you can say? These are same, right? X by m is equal to y by n equal to z by p. Clear? On comparison. On comparison. On comparison, you will get x by m equal to y by n equal to z by p. I'll tell it's equal to k. So you can say x equal to mk. I'll write this name. I'll say x equal to mk, y equal to nk, z equal to pk. So I can say mk comma nk comma pk. Yes or no? Now finally we'll do dou L by dou lambda equal to 0. Meaning we'll get back the condition. What will happen? Add all the equations. We will get m plus n plus p into k will be equal to a. So I'll get the value of k. K is what? A by m plus n plus p. Substitute it back now. What is x, y, z? M a by m plus n plus p. N a by m plus n plus p. P a by m plus n plus p. This is the stationary point. But the question there was not stationary point. This is stationary point. It's given as maximum. Given as maximum. The question. We're asking you to find the maximum value. Find the maximum value, not the stationary point. So you need to substitute it now. What is f max? Do it. Whole power m into whole power n into all that. You will get m power m. What will you get? You will get. Let's see. You will get finally. Yeah. You do that. M power n power n, p power p divided by what will you get? M plus n plus p whole power m plus n. Right? This is what will get, right? What ma'am is written. I'm just copying like that. I'm not going to waste time. It's understandable, I think. I can always do this. You will substitute it. Substitute in f equal to x per m, y per n, z per p. Oh, that. That's it. Now this is these two questions I did. One geometrical question is there. Okay, a geometrical question. One thing is I want to do it full. This question I'm not going to do fully. I'm just going to bring it to one level and show. We are having show that the rectangular solid, meaning they are meaning cuboid. Maximum volume that can be in what is in a sphere is here to show. How to show? Look at this carefully. First of all, what is the equation of cube? Equation of sphere. Equation of sphere is given by x square plus y square plus z square equal to r square. Meaning this is the condition. You understand? This is a given condition because you understand it should be in a cube, right? So this is a given condition for the sphere. Look this carefully. So I'll write g will be x squared plus y squared plus z squared minus r squared. Look at this very carefully. So you understand. You're having a sphere. Let this be center of the sphere. Okay. Now if I want cuboid, if I want a cuboid, I need to take one point here I'll take this point as x 0 0. I'll take one point on y-axis. That will be it will be 0. This is not like it won't be exactly here. No, I'm drawing wrongly. Wait. Where here it will be like this. It will be no. It will be some random. Random it will be. This length I'll take as x. Okay. This length I'm taking as x because you can understand, and this will be y because they are coordinates, correct? Because they are coordinates. I can't take x is x coordinate, so I need to take from center to the edge. I'll take as x. From center to this part, I'll take as y. Okay, because you need to, whenever you're taking x and y, then you need to start using from origin. You can't say that, you can't claim this is x. You can't do that. Okay, I can't give more clarity than this because I myself am not 100% clear on this. You have to take like this only. So if I'm taking cuboid will have dimensions as what? 2x, 2y, 2z. Because this will be 2x, this will be 2y, and this also will be 2z. Okay. So now what I'm doing? Volume will be what? 8xyz. This will take as if. This to be maximized. Logic is it clear? Don't ask me 100% clarity because I myself am not clear. Okay, no, you have to take only this as y, this as x because it's starting from origin. That's all. New clarity. So what you can do? We'll take L as, do it fast, do it. We'll do it, finish it fast. L is what? F plus lambda g. What is L? L will be 8xyz plus lambda into x squared plus y squared plus z squared minus r squared. Do. You will get dou L by dou x equal to 0. You will get 8yz plus, what you will get? Lambda into 2x equal to 0, correct? So from this you will get 4yz plus lambda x equal to 0. And from this, if you simplify this further, you will get, I'll write as 4xyz. No, is it correct? Xyz plus lambda x squared equal to 0. What type x? Just left this, I'm doing manipulation, that's it. Multiplying by x here. Here I'm dividing by 2. Okay, multiplying by x. So I'll just write it fast. So from dou L by dou x equal to 0, I'm getting condition 1. I'm getting 4xyz plus lambda x squared equal to 0. Now similarly, I am not writing an exam, you need to write fully, don't write like me. Okay, similarly, you will get from dou L, what you will get from dou L? Think, no, someone try to volunteer, what you will get for this condition? And what will you get from this? Don't calculate, just try to see the pattern. Come on. Yeah, why no response? Rishabh, Gautam, tell me what you will get.
Yo, 1 second.
4xyz plus lambda y square.
That's it. Do it. No, I told you no, just see the pattern. Do the same thing only. And what you can do? Dou L by dou z is 0. What do you get? 4xyz. Lambda z squared equal to 0. On comparison, what do you get? On comparison?
X square equal to y square equal to z square.
But all these are lengths, no? All positive, correct?
Not necessarily. Xyz points than the plus or.
Yeah, but I'm taking, I'm defining lengths like this, no? I'm defining lengths like this.
போடுற negative possible தானடா.
See, actually what you're saying is correct only. Negative also is possible, but for now you just consider positive. Don't ask more questions. I know. See, this is the problem with the syllabus is they're given very less. Lagrange method itself is a very big method. You should have given full method. They're given very less. So just don't ask. Okay, so you're just writing x equal to y equal to z. Azimuth is k. Okay. So now what you will do? Now what is dou L? What is dou L by dou lambda? Dou equal to 0. What you will get? X squared plus y squared plus z squared minus r squared equal to 0. So you will get 3k squared equal to r squared, k equal to r by root 3. So you will get x equal to y equal to z equal to r by root 3. And if then, and what are lengths? What are dimensions now? Dimensions are 2r by root 3.
2x, 2y, 2z.
That's what. And they are equal, no?
Okay.
So they are cube. So therefore proved. That's it. 4. That's it. Simple. 4 concept over. Concept is 4. That's all. This is how you do this Lagrange point. That's it. Lagrange also I finished. And one more concept also I'll take, which one question I didn't do this model in class. But that's also I'll take. Transformation. Of variables. This also I'll take. If you want, I mean, if you are if you want to go eat, please eat. You can see recording. Anyway, it's getting recorded. No, don't worry. So this concept, if I'm showing what the concept is, I'll give an example. They are giving u as x plus y and v as x minus y, and they're saying they're giving differential equation is dou squared z by dou z squared minus dou squared z by dou y squared equal to 0. So they're saying transform differential equation in terms of u and v. This they're taking transform. Same equation they're giving, but you should transform it in terms of u and v. So what you will do, I'll just finish it fast. Okay. What you're doing is let u be a function of let z be a function of u and v. Now if you observe carefully, u is a function of x and y, and v is also a function of x and y. This you should understand. What I'm doing is I'll do dou z by dou x equal to dou z by dou u into dou u by dou x. All this I taught. Okay. Plus dou z by dou v into dou v by dou x. Correct. What is dou u by dou x? This will be dou z by dou u plus dou z by dou v. That's it. Okay. Then what I'll do now, look at this carefully. So this is the most important part. Look at this carefully. In physics, nuclear physics, sorry, not nuclear physics, quantum mechanics, we learned something called operator. Listen carefully. I'm getting dou z by dou x as dou z by dou u plus dou z by dou v. Now what I'm doing is I am defining operator. Define dou by dou z as dou by dou u plus dou by dou v. That is, I'm defining an operator. You should try to understand. Okay, just like how we did in quantum mechanics. So why I'm doing this is, look at this carefully. Now suppose I want to find dou squared z by dou z x squared. What I'll do? Dou by dou x of dou z by dou x. So what is dou by dou x? Dou by dou x is this operator. Dou by dou u plus dou by dou v. Dou by dou u plus dou by dou v. What is dou z by dou x? Dou z by dou u plus dou z by dou v. Now you need to properly apply the operator. How to apply? Dou by dou u of this full expression plus dou by dou v of this expression. You need to apply very, very carefully. Okay. See this. You will get dou squared z by dou u squared, dou squared z by dou u dou v, dou squared z by dou u dou v plus dou squared z by dou v squared. You will get dou squared z by dou u squared, 2 dou squared z by dou u dou v, dou squared z by dou v squared. Correct? That's it. Now if you are doing dou squared, if you are doing dou z by dou y, this will be dou z by dou u into dou u by dou x dou y plus dou z by dou v into dou v by dou y. This will be dou z by dou u minus dou z by dou v. I'm not wrong. Please sit and differentiate. I want to do all differentiation now. So if you apply the same concept, so now I'll define dou by dou y operator as dou by dou u minus dou by dou v. Now what I'll do? Now I'll try to define. I'll try to do dou squared z by dou y squared. What will be? It will be dou by dou y of what? Dou z by dou y. So dou by dou y is this operator. Dou z by dou y is given as dou z by dou u minus dou z by dou v. Now you sit and expand. Don't I'm warning you, don't apply a squared plus 2 by 2. It won't work. This is a lucky question. It's working. Every question it won't work. So in this question it will work. I'm telling. So I'm doing it directly. Minus 2 times dou squared z by dou u dou v plus dou squared z by dou v squared. Okay. So what I'm getting is, I'm getting two equations. What equation I'm getting? I'm getting dou squared z by dou x squared. What I'm getting dou squared z by dou u squared plus 2 dou squared z by dou u dou v plus dou squared z by dou v squared. Another equation I'm getting dou squared z by dou y squared equal to dou squared z by dou u squared minus 2 times dou squared z by dou u dou v plus dou squared z by dou v squared. Now what I'll do, I'll just subtract these equations. Subtract equations. What I'll get? The equation I'll get dou squared z by dou x squared minus dou squared z by dou y squared equal to what? Equal to 4 dou squared z by dou u dou v. Now look at this carefully. Now what is given differential equation? Given differential equation is what? Dou squared z by dou x squared minus dou squared z by dou y squared equal to 0. Now you can replace this by 4 dou squared z by dou u dou v equal to 0. So I can say final answer is what? Dou squared z by dou u dou v equal to 0. That's over. This is the transformed equation. This is the transformed equation. Any doubt on this? Is it clear 100%? Tell me.
Yes, yeah, it's clear.
Okay, thank you.
Yeah,